Today we're pleased to introduce Joe Judge from the Mitre Corporation. Joe has a distinguished career in information security, particularly network security, dating all the way back to Bell Labs and several incarnations in between. He's been most recently at the Mitre for 5 years. I know he's done some work in looking at forward deployed systems and how to protect network security in those. But today he's going to be talking to us about software assurance.
Thanks. So I'll take a few minutes and maybe I'll cover the what Mitre is first, so it gives you an idea of where I'm coming from. So Mitre is a federally funded research and development center. It's not like a normal company, but it kind of is. So Mitre is a company that is focused on working in the public's best interest. We're not a defense contractor. We work with sponsors that typically would be worked with by defense contractors, so the Air Force, the DoD in general, NSA, FBI, Department of Homeland Security. And each center that we have at Mitre focuses on a different space. I work in the DoD center. So a lot of my work is with the Air Force and DoD acquisitions. And I'm sorry, but software assurance sounds like the most boring topic, and acquisitions to most people sounds like a very boring activity. But for my part of the Air Force that I work with, they procure systems. Again, I'm sorry it sounds boring. What the military has a huge set of folks who are at the pointy end of the stick. There's another set of folks on the backside who help logistically supply them. And that could be from hot coffee to systems, applications, software. And if I can explain to you kind of how my job is affected by software assurance and what's going on in industry, you can probably Google around right now and find really good topics on software assurance that come from Booz Allen Hamilton or from the Mitre Corporation. And they will give you a good sort of basic set of information of what's going on, what you should do, frameworks for approach, tools that you can use. But it might help, I'm hoping, if you get a sort of practitioner's view on it and see how we actually put these things together and why they're important. So I'm going to assume most of you know the basics about software development, and I'm not going to belabor too many points early on to impress upon you how much it's important, but I'll start with the basics. Everything's connected. I know people say that, but I come from a time where I remember the first internet toaster, 1991, the Interrupt conference, and the second year when they actually added a robotic arm to hook up the toaster to make the bread go in the slot. This was clever stuff back then. Today, everything's connected. A toaster is not unique on the internet anymore. Webcams are not as interesting as they would have been before. Remember when the first Encyclopedia Britannica came online, or the Vatican. And these were shocking developments in the early 90s. And what we're connecting now is complex. So we're connecting things behind infrastructures and protections that are also very complex. This is an example of an IBM store, the systems that make a store that you go to, that IBM has control that sells systems and computers. This is their block diagram of the systems infrastructure. That's just a store. So the important thing to me to note is I keep thinking of the internet, I had been, as this thing that's built up of pieces. As engineers, as developers and engineers, we view things as atomic components that you put together, an ISO stack with applications at the top and hardware way down at the bottom, and that we picture an interconnectivity, an internet, a cyber, whatever you want to call it, the matrix, as an expression or outcome of this thing that occurred. But okay, that's true, but flip it upside down. Right now, the internet or the cyber infrastructure connects, underpins everything now. You have a piece of equipment that measure temperature on oil pipeways connected over the internet. You scan enough, you'll find one. There are lots of neat pieces connected to the internet, and these now connect things you wouldn't have thought connected before. So these pieces that we connect, Google today, you hear stories about the United States power infrastructure and Chinese hackers and the ghost net and people are breaking into the power infrastructure. There's one example of sets of computers that control our power, our electrical power infrastructure, may or may not have weaknesses because eventually at one way or another they're connected to the internet. These things are built by people who write software and stick it on pieces of hardware. So this is an example of a software flaw. It's a dumb mistake. I have a floating point integer that's held in a very large sort of 64-bit bucket, and I shove it into a 16-bit integer bucket that's signed. You have to watch out, right? I mean, at some point, you're taking a large number, shoving it into a smaller bucket, and the top bit set, so now it's flipped negative. And if I took 65,536 and shoved it into a long int, signed int, does it make it -1? Or is it 65,536? Signed and unsigned becomes important. All these things become important as software developers. You're supposed to know this stuff. A lot of languages will cast things for you, but how it actually cast it, what was it that happened? And especially for test cases, are you testing that the kind of data that we shove in here is within a certain range so that it doesn't overflow, or are we testing for overflow? But I see it from a different point of view because I've made these mistakes, and they're easy to find, and there's tools available there. But these flaws that we put in, I don't know if it was an accident. This flaw, for example, this exact source code was part of the Ariane rocket. The French, out of French Guiana, they set this rocket off after a decade of work and about $7 billion of programming and time and building and engineering and loading it up with $500 million worth of cargo, and it flew for about 40 seconds. They had a problem with that 64-bit number being shoved into too small of a bucket, and it made a mistake. It didn't cost any lives in this one, but we have examples. The Patriot missile, in the first Gulf War, we had Patriot missiles that would shoot down Scud missiles, incoming Scud missiles, and we had a problem where we round numbers a little bit off. And so it would just miss the Scud, and the Scud would hit and kill people. So my point is, go back a slide, software flaws can have real-world impact, not just financial, but we have software everywhere now. All right. Now, from my point of view, when we're acquiring software, you guys are building software for me. I do care whether it was intentional or whether it was accidental, but at some point, the exercise of that weakness may be intentional, maybe accidental. With the Ariane rocket, it was probably an accident, and actually, the feedback loop to test that variable was too slow, and the rocket was moving too fast. So their correction would start a wobble. And it was an accident. Everything seems to point to an accident. But at some point, the expression of that outcome doesn't matter whether it was an intentionally added flaw because one rogue developer was all pissed off, or whether it was an accident, it was a coding error, that just a mistake, they forgot it in their test case to check those things. It doesn't matter because the actual expression of that and the impact doesn't care. A bad guy trying to hack your system doesn't care how that flaw got there, unless he put it there. He doesn't care how it got there. They're exploitable. They're weaknesses. They exist. I'll try for them. And they're pretty well-known ones, buffer overflows and integer overflows like that. So even blindly, without even knowing the source code, I could test for the most obvious thing, SQL injection, when you take input form from a web page. The traditional mindset for most of the people who work in information security, information assurance, has been focused on, again, that ISO stack at the lower pieces. Firewalls in the 90s, firewalls and network security, and inspection of content flows and system security, and making sure you lock down your system and put firewalls up, or you have host-based firewalls. Maybe put tripwire in your system and look for integrity checks in case something changes unexpectedly on your file system. But if you put all these things in place, and you open a hole through your firewall so people can talk to your application web server, and you reach past the system security and let them reach inside and touch your data or your application logic that you wrote, then they don't really help. Those are just little holes in a fence that someone can reach through. It's about the data. There have been cases in the past, well, I've been doing this 20 years, but bad guys break into a system. Oh, it's the system that financial services has all this money that they move and bank account data. And the guys break into the system. They use that as a hopping point for somewhere else because they didn't know what they broke into. They just were looking for system access to anonymize their connection somewhere else. They could have been rich, but they didn't know.